All right, so for your homework, an object that is moving at a constant speed of 6 meters per second every second. Well, it says it's moving at a constant speed, so what do you think that means? If it's moving constant, right, that means increasing and decreasing. That can't be an option. Not moving, well, that definitely can't be an option. What that is moving, telling you that, yeah, it's going to be letter D. It's moving at a constant 6 meters per second every, right? So every single second it's going to move a full 6 meters. All right. Which of the following is a vector quantity? Remember, vectors need magnitude, unit, direction. Does speed need a direction? No. Does time need a direction? Nah. Does total distance traveled? Nope. But does velocity? Yep. That is also letter D. Now this next one, all right, assuming the positive direction, so to the right, is east, the negative direction to the left is west. All right, here's what's going on. The person is going to move from 0 to 8 meters or kilometers west or east, sorry. And then they're going to move 5 back the next day. So they want to know, what is the net displacement? Well, what that means, right? If we started here, let's reverse that. Let's use, if you guys started here at 0, how far away are you at the end? Right there, which is at 3. All right. Now, what direction is it though? To the left or to the right? Right here. You're ending here. This is where you started. So you're to the right, or in the positive direction would be to the east. So 3 kilometers to the east. Well, what is your total distance traveled? Well, you moved 8, and you also moved how much? 5 back. So what is the total distance that you moved? What do I do with that? Total distance, you add them all together. So 5 and 8, add it together. 13 kilometers. Okay, let's go to the back side. So on this, a balloon goes 140 meters to the west in 45 seconds, right? In 45 seconds. Then the wind changes and it goes 90 back towards the east in 25 seconds. So, how far did it travel in the first 45? 140. Now, distance doesn't need a direction, so it's just 140. How far did it travel during the next 25 seconds? Good, 90. What is the total distance traveled? Well, if you moved 140 and 90, what is that going to give us? 230 meters. Okay, good. So now it's going to ask us, well, what was the displacement during the first 45 seconds? So again, what did it do? It went what direction? East or west for the first 45? West. Okay, so it moved this 140 west, and so that will be your displacement. You have to include the direction for your displacement. Well, what about the next 25 seconds? Well, it went how far to the right? Or to the east? 90. So this one would be 90 meters east. All right, now, what about the total displacement? So for this, you went 140, and then you came back 90. So they want to know this last piece. How far away are you from this starting spot, right? This is where you ended. So how do I figure that out? Well, opposite directions, what are you going to do? You're going to subtract. So what's 140 minus 90? How much? Good, 50 meters. But now what direction are you in? Are you in the west or to the right of where you started? Good, we are to the west, right? Which is, we're still over here, right? We're still finishing over here, which was to the west of our starting spot. All right, good. So we have to write 50 meters west. All right, so now let's roll it up. They want to know what is the average speed for the first 45 seconds. So the speed equation, distance divided by time. What distance did we travel? 140 meters. In how much time? Well, it tells us the first 45 seconds. So divide that out, and you're going to get 3.111 repeating. We're going to round to 2 decimals, so 3.11. And the unit for speed is, or velocity, is just meters per second. Acceleration is the meters per second squared one. All right, well, what is the average speed during the next one? Well, we pretty much do a very similar thing. Speed is distance divided by time. We moved 90 meters during that time, and the time was 25 seconds. Dividing that out in your calculators, you're going to come up with 3.6 meters per second. Ooh, this is a good one. What is the average speed for the entire trip? So, average speed is your total distance divided by the total time. Well, we've already figured out the total distance, right? Over here was 230 meters. But what is the total time? Well, you moved 45 seconds, and what was the other one? 25. So when we add those together, we get a total of 70 seconds. So the 70 seconds is our total time, so the 70 seconds has to go here. So if we throw that into the calculator, that comes out to be like 3.287 or something like that, and change. If we round it to 2 decimals, it should come out to be 3.29 meters per second. All right, we're almost done. We got 3 more. They want the average velocity during the first 45 seconds. So velocity is equal to delta x, which is our way how we write displacement, divided by that specific time. So our displacement for the first 45 seconds was 140 meters west divided by 45 seconds. Now we already did a calculation with 140 divided by 45, so it's going to be the same number. 3.11 meters per second. But now, because we're dealing with velocity, we want to include the direction, which was west. So we need to make sure we have west in our answer. The next one, average velocity for the 25 seconds. So same thing, delta x over t. Our displacement for the 25 seconds was 90 meters east, so we have 90 meters east divided by how long were you moving for in this part? 25 seconds. And that also will come out to be 3.6 meters per second. Is that good? Is that my final answer? No. What do I need? Right, you need the direction. You need east. And then this very last one, average velocity for the entire trip. So average velocity is going to equal, all right, our total displacement divided by the total time. So we found our total displacement of that whole motion was 50 meters west. And what was our total time again? Well, we moved for 45 and 25, so that again comes out to be 70 seconds. So we should have 70 seconds on the bottom. And when we divide this out, we round it to 2 decimals, it should come out to be 0.71 meters per second west. Okay, anyone have any questions? No? All right, very good.